The goal of this video is to use what we know about logarithms to solve equations. All right, so let's look at some examples. All right, and remember what the word solve means. It means we're looking for a value or values that will make our statement true. All right, this first one is a real simple one. I think you should be able to instantly tell what number would make this true. Right? This statement would only be true if x were 2. Right? So we can immediately say that our solution would be 2. Right? Because 5 squared is 25. But what if it wasn't so easy? What if I had something like this? 5 to the x power is equal to 78,125. And off the top of my head, I don't know what value would make this true. Right? And you could, if you wanted to, just plug in 5 to the second, 5 cubed, 5 fourth, 5 to the fourth power, 5 to the fifth. Just keep on going until you make this work. Right? But what we can do instead is we can use a logarithm. Right? We can write a logarithm equation that can help us with this. Right? And this really is the usefulness of logarithms. Right? Because let's think about it. What's missing here? We don't know our x value, and this is the exponent. And remember, a logarithm is the exponent that we raise our base to get this number, 78,125. Right? So x is equal to the logarithm. Right? It's equal to the logarithm base 5 of 78,125. Right? Let's think about that. Does that make sense? Right? Remember, our x, that is the exponent, right, that I need to raise my base to, 5, to get 78,125, right? That's exactly what this is. Log base 5 of 78,125, right? And now we could use our calculator to compute this logarithm, right? And remember, with our change of base formula, to put this in the calculator, we would do log base 10 of 78,125, divide that by log base 10 of 5, right? And we'll use calculators in class. But when you actually compute this, this is equal to 7, right? So this tells us 7 is the number that makes this true. 5 to the 7th power is 78,125. All right, let's look at two other ones. Okay, so this one I've got 6 to the x power minus 5 equals 35. Right. Well, first let's make this equation simpler. Right. I would add 5 to both sides. And so I have 6 to the x power is equal to 40. All right, well, what would this have to be to make this true? And I don't know, because I know 6 squared is 36, and 6 cubed is 216, but I don't know 6 to some power gets me 40, right? And I know this is not going to be a nice, perfect integer. It's going to be a decimal. Right? But again, we can use our logarithm, right? Because this x, that's our logarithm, the exponent, that makes our base, 6, takes it to equal 40. Right? So x has to be equal to log base 6 of 40. Right? Because it's the exponent, right? This logarithm is the exponent that I need to take 6 to become 40. Right? And then again we can use our calculator, and we would use change of base. So this is log base 10 of 40 divided by the log base 10 of 6. Sorry about that. That's a 10. Okay. And again, once you use the common logarithm in the change of base, you can plug this in your calculator, and we find out that this is going to be 2.06. Okay. And we'll practice again using the calculator part in class. Okay. If you have a calculator at home that can do this, that's great, but if not, we'll practice that in class. Okay, so let's do another one here. We've got 140 equals 7 to the x plus 2. Right, and what I want you to notice here is that this time I have this whole thing, this x plus 2. That is my exponent, this whole thing together, x plus 2. Okay, so again, I don't know what this off the top of my head is, but we can use a logarithm here. Right, so this exponent, right, that's got to be equal to our logarithm. Right, because the logarithm is the exponent to which we raise our base 7 to get this number, 140. Right, so our exponent, x plus 2, has to be equal to our logarithm. So log base 7 of 140. Okay, and this, right, I could do on my calculator, right, and then solve for x. Right, I'm going to save that calculation for the end, and what I'm going to do is I'm going to subtract 2 from both sides to get x by itself. So we end up with x is equal to log base 7 of 140 minus 2. Now I want you to be very careful here to note, I'm going to use parentheses here to make it clear, right? Log base 7 of 140 minus 2, that's not equal to the log base 7 of 138. You can't subtract these, right? Because it's this whole thing minus the 2. It's not 140 minus 2. It's this whole thing minus 2. So to actually compute this, right, we can use change of base again. So this would be the log base 10 of 140 divided by the log base 10 of 7 minus 2. Right? And we'll use our calculators to calculate this in class. Right? But that does come out to be about 0.54. All right, we're going to look at a few other ones. Okay, this time our equations already have a log in them. Okay, now this first one is pretty simple. I think some of you might be able to tell what x needs to be. It's 36, right? But let's make sure we understand why this is. Okay, so remember, a logarithm. This is the thinking you need to use, right? Your logarithm is equal to your exponent, and what is this exponent? 2. That's the exponent that I need to raise 6 to get x. So in other words, our x has to be 6 squared, right? Because this 2, that's the exponent I raised 6 to get our x value, right? So x would be 36. Okay. Now, this idea is super useful for when it's a little bit trickier, right? This one you might just be able to do instantly in your head, but this one's a little bit trickier, right? Log base 6 of x equals 3.5, right? So since we have, a decimal here, we got to really think about this, right? But it's the same idea. This 3.5, that's equal to our logarithm. So this right here is our exponent, right? So x has to be equal to 6 to the 3.5 power, right? This is the exponent that I raise my 6 to get x, right? So x is equal to 6 to the 3.5 power, right? And again, this we'll use our calculators for. But if you enter that into your calculator, you get 529.09. We're going to look at one last one, okay? Looks a little complicated, but you'll see step by step it's not that bad. Okay, so first, we have 9 equals log base 7 of 2x plus 5. Right? What I would do first is I would get this logarithm to be isolated. Get this logarithm by itself. Right? And we can do that by subtracting 5 from both sides. So we end up with 4 equals log base 7 of 2x. Okay, and now, again, let's think about this. This logarithm is equal to 4, right? So that means 4 is our exponent. This is the exponent that I need to raise 7 to in order to get this number, 2x. So that would be 7 to the 4th power equals 2x, right? Because logarithm is equal to 4, that means this is our exponent. So 7 to the 4th equals 2x. Okay, and then to get x by itself, we just divide both sides by 2. Right? So x is equal to 7 to the 4th power divided by 2. Right? And then again, this gets pretty big, so we'll use our calculators to calculate that in class. But I went ahead and did it. This comes out to be 1,200.5. All right, we'll practice more of these in class.